Great, folks. In today's class, I'm going to talk about the review. In the last video, which I posted, the review, the audio wasn't working well, so I'm going to try and make this new video for you guys. So in this video, the very first question given to us in the review is convert the angle into the radian mode. So the angle given to me is 230 degrees, and what I did was I multiplied with the pi over 180. So 230 multiplied by pi over 180, the answer comes out to be 23 over 18. So you can leave it as it is, or you can also convert it into the real number. So something like 23 multiplied by 3.14 divided by 18, whatever number you're going to get, that is also correct answer, or you can leave it like this also. Then the question number two, if I look into this one, 3 degrees, and what I did in this one is 3 multiplied by, again, pi over 180, and the final answer is pi over 60 degrees. Let's look into the next question. In the question number two, we are given the 3 radians, and I have to convert it into the in radians into degrees. So now I'll flip it. So earlier I was multiplying by pi over 180 because I wanted the radians on top, because final answer has to have the radians. Now I will have the degrees on top. So 180 degree equal to pi radians. So 180 goes on top and the pi goes on the bottom. And then after doing the calculation, this is the value which I got for the degrees. And same thing gonna happen for the next one, which is 4 pi over 3. So 4 pi over 3 multiplied by 180 divided by pi, that's gonna give me final answer as 240 degrees. All right, let's look into the question number three. In question number three, we are given this question. So we have to prove this identity. Means when we are proving the identity, please make sure you try and work with one of the sides. So either you are working with the left hand side and making it equal to the right hand side, or you are working with the right hand side and making it equal to the left hand side. Don't start intermixing these two. Okay, so let's look into how I did it. So the question says, I'm taking the left hand side first of all. So 1 minus cos x and divided by cos x times tangent x, and tangent x can be converted into sin x over cos x, and then cos x and cos x cancels out here, and I am left with 1 over cos x, 1 over cos x divided by sin x. And then what I'm going to do is I'm going to multiply this with 1 plus cos x. Why? Because I will always keep a check on keep an eye onto the right hand side. What I want here, I want 1 plus cos x on the bottom, and I can clearly see 1 plus 1 minus cos x on top here. So I wanted to convert into 1 plus cos x on the bottom, so I will rationalize the numerator in this case. So multiply by 1 plus cos x and divided by 1 plus cos x, and that on top lead to a minus b, and a plus b, which is equal to a square minus b square. And from there I got this value 1 minus cos square x on top, and on the bottom sin x, and multiply by 1 plus cos x, and then 1 minus cos square x is equal to sin square x. From where I got it, sin square x plus cos square x is equal to 1, and I can write it as 1 minus cos square x is equal to sin square x. So I've converted into sine square x. So one of the sines cancels out, and then I'm left with sine x upon 1 plus cos x, so which is the final answer for uh, our question. All right, now let's look into the question number 4. I guess I missed question number 4 on my sheet. Oops, I got it. So thank you. Oops, I missed it again. 1 second. So let me find it here. So this is the question. Sine of x plus y, sine x minus y. This is the question, and I wanted to again prove the identity, which is equal to sine square x minus sine square y. So I'm going to start with the left hand side. So in this one, what's happening is sine a plus b. So this is the formula I'm using. You can look into your formula, this formula into your formula booklet. Sine a plus b is equal to sine of a cos B plus cos A sine B. That is the formula I'm gonna use for the first part. And here for the second part, I'm gonna use sine A minus B, which is equal to sine A cos B minus cos A sine B. This is the formula I've used for the second part. So that's what give me this and this, these values. And now if I look at these values carefully, this whole thing becomes A, this thing becomes A, this thing becomes B, and again A, B. So A plus B, A minus B, difference of squares formula, A square minus B square. So that's going to give me sine X cos Y, which is A, which is this whole thing is A, this A square, and then cos x sine y, which is b, this b whole square. That's what I did. Now I'm going to move this square to the distribute this square to these two terms, and then here this goes here and this goes down here. And then what I'm gonna do here is I will, as I distributed, this becomes sine square x and this becomes cos square y minus cos square x sine square y. This is where students get stuck and couldn't figure out after this what to do. So what I'm gonna do is I'll look into my answer again one more time. So I want sine square x and sine square y. Okay, so this is cos square y. This is not a needed term. So I'm going to try and remove this because I need sine square x. So I'll leave it as it is. So what can I do with the cos square y? I can convert it into 1 minus sine square y. From the formula, again, the formula which I used previously, sine square x plus cos square x is equal to 1. So sine square x is equal to 1 minus cos square x. That's the formula I've used here in terms of y's I used. And then down here also cos square x I've converted into 1 minus sine square y because I wanted to keep the term. If I look into the question, sine square y I wanted to keep with me. So I will not touch the sine square y. I will change the cos square x. And I convert it into 1 minus sine square x. And now I'm going to open the bracket by distributing these terms. And then again, this becomes sine square y, this becomes sine square x times sine square y. And then these two are like terms with the opposite sign, so these two cancels out, and I'm left with sine square x minus sine square y. All right, now let's look into question number 5. In this question, we are given y equal to minus 2 sine 3x minus pi. And what I wanted to do is I wanted to draw the graph for this one. So I'm going to compare it with the equation y equal to a sine b plus c plus d. So this is the standard form of an equation. And if you don't remember, please make sure you watch the previous video also. And now A is the amplitude. So amplitude comes out to be 2. So this is where a lot of students make a mistake where they end up taking amplitude as minus 2. This is not minus 2. This minus is going to represent the reflection. So you're only going to take the number, purely number for representing the amplitude. It can be minus 2, minus 3, minus 4, but you only going to take the number there. Okay, so we got the amplitude value, and then the time period. Time period is 2 pi upon b. This is the formula, and if you wanted to write down this formula on your formula booklet, you can do that also. That is for time period if it is not given to you. So now 2 pi, this will become 2 pi upon b value is, so I cannot take this 3 as the b value because this 3 belongs only to the x. This is not common to all the terms. If I see this b is common to both the terms, so I need to take this 3 out first of all. Whatever is with the x term, we have to take it out. Okay, so what I'm gonna do here is I'm gonna take 3 out. So I've taken 3 out and left with x inside and pi over 3. That's what I left with. So now this is what I'm gonna take. So 2 pi upon 3, that becomes the time period because 2 pi upon b is the time period. Now from here, I'll be able to figure out the horizontal shift. So this C portion will be the horizontal shift. If I won't have taken this 3 out, then the horizontal shift would have been different. So please make sure there is nothing in front of X. Now we got this value. So I'm gonna take this. This is pi over 3, and this there is a negative sign in front. So negative means you are moving to the right. If this was a positive sign, you are moving to the left. If it is a negative sign, you are moving to the right. So please make sure you watch the video thoroughly. I mean, if you're confused, the video I've posted on this, please make sure you go back and watch those videos so that you can understand why I'm moving to the right. All right, so pi over 3 is the face which I moved to the right. So this is how I'm going to start drawing it now. I have all the terms. So I will start with the pi over 3 to the right. This is pi over 3 because this is a phase shift given to me. And then the time period is 2 pi over 3. And there is a reflection, a negative reflection in the question, a negative is there. So I'm going to start drawing it from the bottom, move towards the right on top. That's how we're going to draw it. And then from pi over 3 plus 2 pi over 3, whatever this point is, that will come out to be pi. So that's the final point. So this whole is time period, which is 2 pi over 3. 2 pi over 3. And then you can also always find the midpoint by subtracting uh, uh, pi minus pi over 3, which is equal to 2 pi upon 3. And now the halfway, if I wanted to find the midpoint, this how we gonna find out? We're gonna say what is the half of 2 pi over 3, which is divide this by 2, which is 2 pi over 6 halfway. So that will be pi over 3 plus 2 pi over 6. You're gonna add this to the term. So that's gonna give you, so that's if you multiply this with 2, this with 2, that's going to give you 2 pi plus 2 pi. This is 6, this is 6, which is 4 pi over 6. Ironically, it came out to be 2 pi over 3. So the midpoint comes out to be 2 pi over 3. All right. And then same way you can find out these 2 points also. Again, if you want those details, that few details are provided in the lecture video on the graphing. So hopefully you were able to understand how to draw these graphs. And now the next question, which is secant theta, which is equal to 1.345, and cos of phi, which is less than 0. So here I wanted to tell you guys, please make sure you guys watch, you guys do thoroughly the questions from exercise 8.2, which are from question number 33 to 38. So do those questions thoroughly. And if and I am talking from the Washington textbook 11th edition. And if you're not using 11th edition, please you can always call me and I can help you. The question given to me is secant theta is 1.3345 and cos theta is less than 0. So what I'm gonna do here is actually I'm gonna tweak this question because this question is not exactly right. I'm gonna mark this one as cos phi is greater than 0. That's what I'm gonna mark this as. So in which quadrant cos is positive? Cos is positive in the first and in the fourth quadrant. So I cast CAST, that's what I'm using. So cos is positive in these two quadrants, and secant is a positive value. So I can write secant as 1 upon cos of phi, which is equal to 1.345, and then you can reverse the position, cos phi equal to 1 upon 1.345. So you're flipping them by placing 1 on the bottom. So phi value will be cos inverse of 1 divided by 1.345, and you're going to get the value as 0.7. Phi value will come out to be cos inverse of 0.7435, which is 41.9 degrees. So this angle 41.9 degrees. So again, cos has to be positive. I changed the question from the review, okay, because that wasn't the right question, so it has to be positive. So angle is positive in which two quadrant? Angle is positive in the first quadrant and in the fourth quadrant. So this is 41.9 and this one down here 41.9, and then you can always find out the principal angle from there. So 360 degree minus 41.9, or approximately 42, and that's going to give you the angle. And then question number 7. So in question number 7, we are given this point and we wanted to find the tangent of this point. So this is pretty straightforward. So you're going to write down negative. Where is the negative 1? X value is negative on this side. Y value is negative down here. So this is the value. So negative 1, this is negative 3. And then you got this point as negative 1, negative 3. And then tangent theta is equal to negative 3 upon negative 1, because opposite upon adjacent side. So theta value will be tangent inverse of 3, which is going to be angle will be approximately 71.56 degrees. So you got this angle. So now the question number 8. So again, in this one, I can clearly see I've used the formula sine x plus y is equal to, or x minus y. That's the angle I've used, x minus y, which is equal to sine x cos y and minus cos x sine y. So this thing becomes x, whole thing becomes x, this whole thing becomes y, this becomes x, this becomes y. And then when you club them, make sure this is like this, 3x minus y. Once you're going to open this, so this is going to become sine 3x minus, will distribute itself here also, minus 3x minus pi. Okay, so these two cancels out. Sine of minus pi will be 0. All right. Well, this minus minus will become plus actually. So this is plus pi. All right. So sine of 180 plus theta. Again, please make sure you guys watch the video on this, how to find the reference angle and the principal angle. That's really important. So what I've done is sine 80 plus x. So this is where I am, this, because this is 180 plus x. So sine is negative in this quadrant. So I'm gonna say negative sine x. In the third quadrant it is negative, so the final answer is negative sine x. Down here, this is the this is again a trigonometric ratio which I've used. This formula is given to you in your formula booklet too. Sine of 2a, that is the formula I've used, which is equal to 2 sine a cos a. And so here it is 6 given to me. I can write it as 3 times 2 multiplied by sine of 5x times cos of 5x, and then which I can convert into sine 2a. So that I will show you here. 3 times this thing becomes 2 of this becomes sine of 2 times 5x, and which is going to give sine of 10x. So that's your final answer. So hopefully you were able to understand these concepts. So I'll see you with another video. Till then, goodbye.